Exponential models, page 3, exercise 4T, number 1. For each function, write down the coordinates of the point where the curve cuts the y-axis and the equation of the horizontal asymptote. Hence, sketch the graph of the function. So this is just like the others. If you put it in the calculator, you can see exactly what the graph is going to look like. Oops, I need to put 2 there. And then to this exponent negative x plus 2 graph. Okay, and then it's kind of hard to see on the graph what the points are, so then we just do second table to see the points. So negative 1, 10, 0, 6, 1, 4, 2, 3. Let's see. So I'm just going to draw the x and y axis. Negative 1 comma 10 would be there. 0, 6 would be there. 1, 4 would be here. 2, 3 would be here. Okay. And then, so the y-intercept, where it cuts the y-axis, would be this point here. Okay, it would be 0, 6. And let's see, the asymptote. The horizontal asymptote is the line that it approaches as x goes to infinity. So let's see. We got x equals 5. We can see at x equals 5, y is 2.125. Let's go up to 10. X equals 10, y is 2.0039. Y equals 15, or x equals 15, y equals 2.0001. So you can see that it's getting closer and closer to 2, but it just doesn't get there. Okay, now on the calculator it says at 17 that it gets to 2, but actually it's just like too small to display. So we can see that the horizontal asymptote is 2. So you could draw a dotted line to represent the horizontal asymptote and show that the exponential function is approaching y equals 2, but never touches it. And remember, like when you write the equation of a horizontal line, the way you do it is you write the y variable equals 2, or whatever the height of the line is. Okay, so we got the horizontal asymptote, we got the y-intercept, and we have the sketch. We'll continue now with the problem from page 4, exponential models, page 4, exercise 4U, number 1. Sketch the graphs of f of x equals 2 to the x plus 0.5, g of x equals 2 to the negative x plus 0.5 for x is between negative 3 and 3. So let's see. Let's draw our x and y axis. And so we're going to graph it between negative 3 and 3. Write down the coordinates of the point of the intersection of the two curves. Well, as we always going to do, especially with this unit, we are going to put the graphs in the calculator. So 2 to the x plus 0.5 would be one of the functions, and the other function is 2 to the negative x plus 0.5 graph. That was one of them. Ooh, and that's the other one. Now, I think I did something wrong. Let me just make sure. Oh, look what I did. I put plus 5 instead of plus 0.5. Because I was expecting them to be kind of symmetrical. Now I can see that I typed it in wrong. 0.5. Okay. So now I should see that they're, kind of like mirror images of each other. Okay. So now you can see that they kind of intersect in the middle. Now to see exactly where they intersect, you could use second calc and intersect, but probably an easier way is just to like look at the table. Let's look at closer to x equals 0 where they intersect to see where exactly they intersect. Oh, there we go. Do you see? So at x equals 0, the y for one of the functions is 1.5, and the other function is also 1.5. So they intersect at the point 0, comma 1.5. Let's mark that on the graph. Or we'll mark it here. 0, 0, oops, 0, 1.5, 0, 1.5. Now the first function at -3 is equal to 0.625. At -2, it's equal to 0.75. And at -1, it's equal to 1. And at 0, it's 1.5. And at 1, it's 2.5. And I'm just copying these numbers from this table right here. Do you see? And 2 is 4.5. And 3 is 8.5. Now let's look at the other table. Hey, what do you know? Look at that. It's the mirror image. So -3, comma 8.5, -2, comma 4.5, -1, comma 2.5, and then 0, comma 1.5, and 1, 1, and 2.75, and 3.625. Now let's graph that. So we're going to graph this one first. -3, comma 6.25 would be around there. -2 to 0.75 would be around there. -1, 1, that would be there. 0, 1.5 would be about there. 1, 2.5 would be about there. 2, 4.5 would be about there. And 3, 8.5 would be right there. So that's one of the curves. And the other curve, -3, 8.5 would be about there. You can see we're making a mirror image. -2, comma 4.5 would be there. -1, 2.5 would be there. And 0, 1.5 would be there. 1, 1 would be here. 2.75 would be there. 3.625 would be there. So it would be like that. And so the intersection point would be 0, 1.5. Okay, and that's one of the things that they asked us for, the point of intersection. Okay, and then write down the equation of the horizontal asymptote. Okay, so what line do these functions approach when x goes to infinity? So like this line, is it going to 0? This line, is it going to 0, or does it go to some other number? Well, let's just look at the table here. Let's look at this one here, because this one, do you see how the 0.625 is getting smaller and smaller? Is it going to 0, or is it going to some other number? Hey, it looks like it's going to 0.5, doesn't it? Yeah, there it went to 0.5. Okay, it doesn't actually touch 0.5, but it gets very, very small, so the calculator can't display it anymore. So the asymptote for at least one of them is y equals 0.5. Does that make sense? Yeah, because if you take this 2 to the negative x and you make it go to infinity or a big number, it's going to be 2 to the negative, like let's say 2 to the negative 100. That's equal to 1 over 2 to the 100. So it's like a huge number. 2 with 100 0 times. I mean, it's 2 times itself 100 times. It's a huge number. So So this is actually a really small number because 1 over a small number, or 1 over a huge number, it's equal to a small number. So like this, depending on which way you go, becomes 0, and then 0.5 is left. Okay, but if you don't understand that, you can always just use the calculator. And let's check this function. We're going to go up, up, up until we get to where this function becomes, a certain number. Let's see, 0.625, 0.56, 0.53, 0.51, 0.50. Hey, it's getting smaller, but it just keeps getting close to 0.5. It doesn't get there. Okay? So, yeah. Here it looks like it gets to 0.5, but of course it doesn't really get to 0.5. It's just like too small, the difference between 0.5 and the number, to show it here. So the asymptote for this function is also 0.5. Y equals 0.5. Okay, so my drawing is a little off. It should go to 0.5. So write down the equation of the horizontal asymptote. There you go. So we have the graphs. We have the point of intersection of the two curves, right? It's the same point, and we have the horizontal asymptote.